Hello, welcome back. We are working with Zener diodes in our circuits. Let us look at how to solve this problem on a Zener diode. Heads up, this question appeared in GATE 2019 ECE paper, and it is a nice concept to understand how Zener diodes work and what are the modes of operation that they are taken into. Let's define the problem. The given circuit has a voltage source Vi. In series, there is a resistor R1. Across both these elements, we have a Zener diode Z and a resistor RL present. It is given that the breakdown voltage of the Zener diode is about 20 volt, and the maximum current that can go through the Zener diode is 60 milliampere. The value of the resistances R1 and RL are 200 ohm and 1 kilo ohm respectively. Now, let us understand how to solve this problem. Zener diode operates in two modes of operation. One is off and one is on. In the on is where it has happened after breakdown. So after breakdown, the Zener diode acts as a voltage source in it. Now let us draw the equivalent diagrams in these two respective conditions. When the Zener diode is off, we only have the supply voltage Vi, resistance R1 and the resistance RL. Let the output at the load resistance be called V0. So the V0 is given as the voltage division ratio times the input supply. So that is given as RL by R1 times Vi. So RL by R1 is given as RL by R1 plus RL. So the values are given as 200 ohm and 1 kilo ohm. So effectively it is 1 divided by 1.2 times Vi, or V0 is 5 by 6 Vi. So this is 1k by 1.2k. So this is one equation. Right? Now what happens when it is on? When it is on, Zener diode acts as a voltage source. So when you set it in that case, in the breakdown side, so the equation, the circuit now becomes as follows. Right? This one you can treat it as 20 volt applied here, and this is the resistance RL. Now in this case we have two loops, loop 1 and loop 2. So let us apply KVL in this case and find out what is the answer. Here we get, in loop 2, the current flowing to RL, I will call that as IL, and this current through R1 can be called as I1. So let us find out what are IL and I1. IL is given as the voltage across the Zener diode, which is 20 volt divided by RL. So 20 divided by RL is 1k, that is 20 milliampere. Next, this is for loop 1. Loop 2. For loop 1, we will get the current I1 is given as Vi minus 20 divided by R1. How much is R1? R1 is 200 ohm. 200 ohm, right? So this is I1. Now we need to find what is the range Vi that can maintain such that the Zener diode is always in on state. So to find out what this value, we need to find the equations as follows. Now if you understand, there is what is the current flowing through the Zener diode, right? So the current flowing through the Zener diode, the maximum current that can flow is 60 milliampere, right? Now if you find out what is Iz, so if you apply KCL at this node, so KCL at that node gives you I1 is equal to Iz plus IL, right? So now we have Iz equal to I1. I1 is Vi minus 20 divided by 200, and IL is 20 milliampere, right? So with this one, now we have found out. So for maximum, for Iz max to be here, so the maximum amount of current that you can support is 60 milliampere. So this value in all conditions has to be less than 60 milliampere. Now if you simplify, we can get the voltage Vi, right? So Vi minus 20 divided by 200 is less than or equal to 80 milliampere, right? And now if you simplify, what are the value you will get? So Vi minus 20 less than or equal to 200 times 80 is 1600, 16,000. 16,000 into 1 milliampere will give you 16 volt. So Vi is less than or equal to 36 volt, right? So this is on the higher end. What about the lower end? For the lower end, the maximum voltage you can get from loop 1 is Vi loop 1, Vi plus voltage across the resistance Vr. So Vr1 is equal to 20 volt. This is the maximum across the volt. So from this we get what is Vr. Vr is Vi plus Vr is R1. So that is 0.2 kilo ohm times current flowing through this is I1, right? What is the current flowing through I1? When this is there is no current that can flow through here when in this particular case, so it will be whatever is the value that you up here. So this is be about 0.2k into 20 milliampere equal to 20. So this gives Vi is equal to k gets multiplied by k, this decimal goes off, so this becomes 4. So 20 minus 4 is equal to 16 volt. Oh, apologies, this is the current flow will be inverse. So this is Vi minus Vr. So what is the, so the voltage will go minus plus minus. So you will actually see the minus sign. So this will effectively become plus. So this is not 16, it is 24. 24 volt. So these two are the answer. So the answer to this question is, so the range of Vi that will maintain the Zener diode in on state is Vi has a minimum value of 24 volt at a maximum value of 36 volt. So this is the answer. Thank you.